Thank you, Mr. Chairman, for my introduction. Today I prepared a short contribution about the estimation of the Greek propagation direction in mixed mode geometry via multi-parameter fracture criteria. I think every one of you know classical fracture mechanics, that we use the first term of William expression. Some of us use two-parameter fracture mechanics that use the stress intensity factor and T-stress. We are now more focused for multi-parameter fracture mechanics, that we use more member to describe the stress field in front of the crack. And then, if we know the stress field, we would like to introduce this member inside the criteria for crack propagation. Therefore, that three major steps toward aim. We did the parametric study, which carried out the mixed mode geometry, and then initial angle of crack is investigated for a wide range of mode mixing situation. Then we use the multi-parameter form of two commonly used fracture criteria. The first one is maximal tensile stress, and the second one is stress energy density. And then we discuss the influence of considering the high-order terms of the William expansion. Okay, for a short review, William expansion and multi-parameter fracture mechanics concept is shown. We can see the stress for the mode 1 is the first member of the first equation. The second term it is for mode 2. Therefore, there is the mixed mode of mode 1 and mode 2. And the second equation it is for the displacement. For the calculation of the member of the William expansion, we use the overdeterministic method. This method is very easy to use. That we take some from a ring, we take some values of the displacement, and then we give inside the matrix, and we obtain the member of William's expansion. Here we can see the two criteria which we use. It's maximum tensile stress criterion. The crack are going to propagate where the stress has this maximum. On the right side we can see the equation for classical fracture mechanics, that we use only first member of the William expansion. Below we can see the strain energy density criterion. That this criterion says that the crack are going to propagate if we obtain the minimum of this value. The last equation, it is how we are going to calculate the stress energy factor from the stresses. For evaluation of our results, we use this geometry. This geometry is eccentricity asymmetric 4-point bending beam specimen. You can see here what is so important. It is the length of the specimen, the width. Here you can see the eccentricity of the specimen, which give us different mixed mode for the crack length. The numerical study was performed in software analysis. It is finite element software, and we use Young modulus. It is 40 gigapascal post ratio 0.2, and the force which we use for the load, it is always 4 kilonewtons. For the study of the influence of the distance, we use different values of the ring around the corrective. It started 0.2 up to 3.2 millimeters, and this, when we obtain the values, we use these values and we give inside the criteria, both criteria. Now you can see the result of maximum tangential stress criterion, and you can see on the table that the left side, that is the initiator angle, then different distance from the corrective, and as was shown on the figure, that there is the different eccentricity. First it is from eccentricity 0, 0.1, 0.2, 0.3 and 0.4 when the corrective is against the force. From the first line you can see influence of the distance from the corrective. If we take from the 0.2, we are surely in the small scale yielding, and all values is practically on the same line. When we are going more far from the corrective, you can see that the values for the first member, it is green line, and for first and second, then black brown line, that for the other multi-parameter used criteria, we can see that this is slightly far from this criterion, especially when we are 3.2 millimeters far, that different level of the members give us different value from this criteria. When we move more to other eccentricity, you can see that on the last row that this criteria it is not on the same line. You can see that for the different mixity of the criteria, for the first ring 0.2 always lying on the same line, where is the dominant of the stress intensity factor. Now we can compare the stress energy density criterion. You can see that first line for this criterion is practically the same, and all lines for the different distance, it is one line. Then you can see that for different eccentricities, the first row of the table, that when we are in the really near the second survey, that the correct is almost, the relative correct length is almost 1, that this criteria give us not correct values. But from for the first 7 relative correct ratio, we obtain always the same line for all values, not only for classical fracture mechanics, but for 2 parameter and for more multi-parameter fracture mechanics, up to if we use values from finite methods that we obtain for infinite number of parameters. Let me conclude. Our paper is focused on the application of the multi-parameter fracture mechanics approach to task of the determination of the initial correct propagation. The parametric study is performed on eccentricity asymmetric 4-point bending specimens, and we use for this evaluation 2 parameter fracture criteria and 2 criteria. It is maximum tangential stress, stress energy density, and
we calculated the angle, initiation angle for crack propagation. Thank you for your attention.